My aim for this episode is not to give you some fast profiles or tell you one simple trick to print faster, because that's been done time and time again. I'm guilty of it as much as anyone. This is actually going to be a multi-part series where I run through most of the parameters that matter most when trying to print faster, and also to explain why it matters, to take the time to say what these settings do and why you might or might not want to use them. And I want to show you the time savings that you can get to put it all into context. I'm primarily focusing on Cura with this video series, but the bulk of the parameters apply to pretty much every other slicer too, so don't tune out if you use Prusa Slicer, this applies to you. Anyway, let's go. This video is sponsored by PCBWay, which I will talk about later on. Thank you PCBWay for sponsoring this episode. I'm going to start with a straight install of Cura and the default Ender 3 profile, because it's the most common basis for most bedslinger printers. In fact, if you're adding a no brand or not already existing in Cura printer, then the Ender 3 is the profile that you generally should start with. So I think it makes most sense to start with it. It's also a fairly sort of vanilla profile. If I started with the FL Sun V400 profile, for example, then I'd have to unwind a lot of the work to show you how to tune it, because they already did. Anyway, before I start though, I'm going to just mention that you need to change your settings visibility to all, and if you don't create your own profiles yet, or haven't, or don't use Cura normally, it's literally as simple as changing any parameter and then selecting to create profile from current settings. Editing after that, you would then choose update profile instead, which is grayed out because the standard profiles are read-only. I'm also running these tests on the Ender 3 S1 Plus, which has the Sprite extruder, and I'm going to therefore just drop the retraction before we start to make that work properly, because an Ender 3 is Bowden and has 5mm retraction as default, so 1mm will do. So I'm going to get straight into it and begin with layers. Layer parameters are some of the easiest things to tune for speed, and they're also pretty simple to understand. The most basic parameter is layer height, and if I have to explain that to you, then it's easier done visually. And of course, even if you understand what layer height is, which most of you do, it's still quite stark when you see it. If you think about the one with the taller line height, the higher line height, fundamentally it's printing at the same linear speed, so the print will be done in a quarter of the time because it's only printing every fourth layer compared to the other. So without changing anything else at all, straight away we can raise the line height and save ridiculous amounts of time. Of course, the cost here is primarily quality. You could think of quality and layer height as inversely proportional. Mathematically, they're not, obviously, unless you invent an SI unit for quality. I could do that now. Let's call it the Trevor. There we go, fixed. There is some nuance to this trade-off as well, which we will cover more in episode 3. But for now, I will just recommend that line height should be between about 0.05 and 0.3mm for a 0.4 nozzle. These are guidelines and they're meant to be broken, and I do recommend sometimes going outside of what's expected with 3D printing, because you never know. But really they're just intended to let you know what kind of parameters will work well. In fact, they're not even generally true. As you know, if you've seen my extreme vase mode videos, that nozzle size itself doesn't dictate line height. Extra points for telling me what does in the comments. But the point I'm making here is that for normal profiles, these are the kind of ranges that you have to play with. So this is one of the biggest things you could change to increase speed at the expense directly of quality. There is a setting that you may be aware of that can work as a compromise between line height and speed and quality, and that is the one that I asked you all about a couple of weeks ago in a poll, adaptive layer height. It's actually meant for raising speed at zero expense to quality, and that sounds really cool on the face of it. I didn't ask you all for fun though. I do plan to make an actual complete video about it, including looking closely into some of the issues that a lot of you raised with the results being apparently less than great aesthetically. But this function does exist. Your mileage may vary. I think it's highly dependent on the model, probably dependent on the overhangs. I ran a couple of tests here and I found this, but this is just scratching the surface of adaptive layers, and as expected for Cura, there's a lot of parameters to mess with, so yeah, it's going to get its own episode. Line height isn't the only thing you can change to achieve greater speed though, and the second parameter I want to look at is actually not necessarily at the expense of quality. So this is one that I use a fair bit, and that is line width and number of lines. And this is also why this tutorial relates to Cura 5 onwards, because the rules kind of changed a little bit with Arachne. But we will talk about that in, I think, episode 2. In Cura, the latter parameter is called number of walls, and it is literally the number of walls of the printer, like you can see. Again, there are nuances to this, but fundamentally, more walls takes more time, and you can print more walls and thinner walls, you can print less walls and thicker walls. Arachne will try to balance out the number of walls you've selected with a line width to try to stop there being any gaps. We talk about that later. For the range that you should be changing for line width, I'll link it below, but I do also recommend some consideration to our later discussion on Arachne, because it is also changing line width. I tend to leave line width most of the time, especially more these days, but I do change number of walls almost every print. Again, significant gains to be had here. The trade-off, though, with number of walls is, of course, the strength of the part, and in some cases, the opacity, too. In these videos, I don't just want to trawl through in order because I think it will get a bit dull, so I'm going to hop about a bit between concepts. And what I want to talk about in the third half of this episode is cooling, and why it slows down benchies. Before I get into that, let me show you the print quality and speed of this printed logo our sponsor PCBWay sent me, because it took me 0 seconds to print this because they did. And I can't even see the layer lines, because it's resin, obviously. We've done that joke. I am informed that this is made from UTR-8220, which is a catchy name. It glows under UV, and that's cool, is it not? That is definitely cool. I need to do an episode on UV at some point, because look at it. And this kind of behaviour actually goes way beyond glow-in-the-dark filament. Anyway, I digress. PCBWay have also sent me a sample of, I think, just about every colour of PCBs that they currently do. I was thinking blue before was best, but now I prefer orange. Orange looks really cool. Let me know in the comments what you prefer. There's also this clear resin print made of UTR-8100, which is impossible to do with FDM. Printing resin is super easy with PCBWay, and you don't even need to get the protective gloves out or deal with the resin at all, which I definitely am a fan of. It makes me think that maybe I will actually just continue to skip resin printing personally, because it sounds like a hassle. What do you think? Anyway, thank you PCBWay for sponsoring this episode, and now back to the benchy thing I was talking about. Did you ever notice how the thing slows down when it's printing the chimney? There is a reason for this, and it is cooling. The quicker you print over and over in the same position, actually, I'll show you. This is colour changing filament, thermochroic if you want to be posh. As you go up layers, the previous layers stay warm, and you can see that. This changes colour about 40 degrees C. As you can see, when you print the chimney part, the whole thing stays warm. Solution? Minimum layer time. It slows down the print to make each layer a minimum of whatever you set it to. But when you want to print fast, then you want to turn this off. But of course, you're going to sacrifice print quality because you don't have functional cooling, but that is the trade-off. Improving cooling will help this, obviously. Okay, so I think we have time for one more quick one, and that is path optimization. Z-hop, turn it off. It takes ages. In case you don't know what Z-hop does, it raises the nozzle every time the printer travels. Travel meaning movements without extrusion. You can get away with Z-hop being quite fast on the Delta, so not that big a deal, but on a Cartesian like an Ender, which has a screw thread to raise and lower the Z-axis, even a 2mm Z-hop can add a lot of time. Secondly, in this section is combing, which very much the same reason, but on the other hand, this should be one of the last things you consider turning off completely. You might want to use not on outer surface, for example. I may do a whole episode on combing in the future, not related to this series, because it is quite confusing to the point that I would have to sit down and understand it first. Okay, that is about it for this episode. On screen now, there ought to be a graphic telling you what we covered here or what improvements we saw. I'm going to hopefully, I don't like promising things I haven't made yet, but I'm going to hopefully supply Patreon members with some kind of short guide in PDF after all these episodes to pull everything together. If you think that sounds cool, then Make sure to check out Patreon, links are below. I do appreciate everyone who already supports the channel through Patreon. It is, of course, a huge help, and I am going to try and make more things available to patrons in future, but that is going to be an interesting challenge because, yes, that is quite literally a paradox. But anyway, this is the end of this episode. Make sure you are subscribed and have smashed the bell and poked the whatever so that you don't miss the next installment where we will talk about Jerk. Yeah, and Infill, and Arachne, and who knows what else. Let me know in the comments what you think, or just yell first in the comments even though you're not. That's also fine. I will see you next time. Thank you for watching.